Hello everybody, welcome to another video. In this one we're going to be talking about the super fun deep learning framework called PyTorch. So what we're going to do is we're going to define a simple model and we're going to sort of say what the forward pass looks like and then give it a loss function and an optimizer and then run a training loop, excuse me. So let's just get started. I know that's a bit confusing because I didn't really do anything, but let's get started. Let's first import some libraries. So we're going to need torch, obviously, and then we're going to need torch.nn. We're going to use it as nn, alias it. Then let's see what else. We're probably going to need pandas and to import some data. And let's also get numpy as well, just in case we need that. And I'll probably plot something. Maybe we'll do that in the next video. So okay, let me show you what we're doing here. So I've got this file. It is just a basic Excel CSV file of a year's experience column and a salary column showing the correlation between, or the relationship between, how much experience you have and what your salary should be according to how long you've worked in a certain industry or whatever. So we're going to basically train a model to find this relationship and then basically predict what your salary should be based on how much experience you have. Okay, so very simple model. Many would argue that I'm not going to have any hidden layers or anything, and many are going to say, oh, what a waste of time, blah, blah, blah. You don't even need, I mean, I guess it kind of defeats the purpose of a deep neural network if you don't have like any nonlinearities or a lot of layers, but that's okay. This is just so we can learn basically how PyTorch works. So let's go ahead and keep going. And so first thing we'll do is I guess we'll import it. So we'll say dataset equals pd.read CSV, and I have it in the same folder. It's called salaries. Okay, then what we can do is sort of extract our columns. So let's just say x, and I'm going to call this x temp because I'm going to be doing stuff to it before I actually have the real x that I want. So for now, x temp, we're going to say dataset iloc, and we're going to want all the rows and up to the right before the last non-included column. So we'll say dot, and we want the values of that, which is our dependent or independent variable, excuse me, in this case salaries. So then we'll say y temp, which is what we're going to be predicting later, is all the rows from the first to the end. So we only have two columns, so basically this is going to be the last column, which in our case, let me bring this back, is the salaries that we want to predict. Okay, so we got our x's and y's. Now, if I'm moving a little fast here, I apologize. Maybe you want to watch it in a slower speed. So next thing we can do is actually turn these into torch tensors, which are sort of like the matrixy data structures that we use in PyTorch. Okay, so just like in TensorFlow actually. So we're going to say torch.float tensor, and actually I think you could probably just get away with just doing tensor and it defaults to a float tensor, but we're going to say float tensor and we're going to pass an x temp. So we're kind of converting these. So then we'll do the same for our y variable. We'll say y train equals torch.float tensor, and keep in mind here I am not going to be splitting this into a training and a test set just because it's a simple example, okay, and we're just training. Yes, this is probably bad practice. You want to have a test set so that later you can see if it worked. But I mean, we only have a couple data points, and I'll be able to see if like it's correctly fitting the line. We'll see. We don't need a test set right now. So let's keep going here. I could probably run this, and you would see. Let's do it. Let me show you. We'll just do Python simple reg.py. Ooh, let's actually print something out. So let's do like print x train. Warming up, sorry. Come on, computer. Let me pause this here. Okay, there we go. So now you can see there's our tensor of basically our x column, our x variable, which is the year's experience. Okay, so this is the independent variable. All right. Same would happen if we did y. You would get the salary data. So now what we kind of do is we say what the model architecture is. So kind of hoping you got a little bit of knowledge of like a neural network. Basically, you have all these layers, so that's what we're going to say here. So we'll say class model, and we're going to inherit from the nn.module from pytorch so that we can use all of its cool functions, and then we'll create an init, and then we're going to have to do one of these super inits so that everything is okay in the method resolution order, so that there's no like huge conflicts. Then we'll say self.linear, and this is just going to be the name of our layer. You can call it whatever you want. We're just going to have a simple linear layer. So we're going to say torch and then linear. Now, and that's it. That's it for like the structure of our model. Now, I'm probably going to get complaints, that's okay, about people saying, hey, this totally defeats the purpose of a neural network. You know, we're just trying to see the PyTorch, you know, kind of flowy here. So you could just as easily add more layers, you know, and then after that add some nonlinearities. But let's just do this for now. Okay, so after this we say what our forward pass looks like. So I'm going to say def forward, pass in self, and we're going to say that our prediction is going to be calling linear with the model, and then let's just return that ypred. Okay, cool. I guess I kind of glossed over this. I should tell you it. So here we're just basically saying we're going to take 1 and output 1. Okay, so that's what you should know. You're putting one feature in, getting one feature out. Okay, so we got our forward pass defined. Very simple. Okay, like I said again, you could from f, you could say torch.nn.f, I believe, and add like a ReLU or a sigmoid or something, depending on the problem you're doing. So let's just continue here. So we'll say our model is going to be an instance of model. And then what we can do is define our loss functions and the optimizer that we'll use. Okay, basically the method of gradient descent we're going to use. So let's just say our loss func equals to nn.msc loss. We use mean squared error loss, and that's it. Okay, then we'll say the optimizer, we'll just call it optim. And by the way, I think it's PyTorch convention to call this like criteria or something, I forget. But anyway, read the docs and see if this should be loss function or criterion. Maybe it's criterion. Anyway, I'll just call it loss function for now. So we'll say optim torch.optim.sgd, and we're going to pass in model parameters, which is where all of our weights are held. So basically, when you create this optimizer, you pass in all of your model all of your weights. You know, this has all the learnable parameters of your model, and we're passing that to our optimizer, which in this case we're going to use stochastic gradient descent. And you could actually see all these if you want, but it would probably, if your model is big enough, it's going to be like like thousands, like, or hundreds of thousands, even millions. So, and you get this from the NN module that you're subclassing here. So let's then we're also going to need to pass in a learning rate. So we'll just say LR equals, and I'm going to do 0001 just to make sure that it works, and we don't get like infinite values or not availables or something. So after that, we can then sort of like define our training loop, which is like a really explicit way, I think, of setting up like your whole training process. So I like it. So we're going to say, we'll say here, training. So it's for epoch in range. Let's just do like 200 for now. And obviously the longer you sort of run this, it'll approximate better. So we'll say y pred is equals to model passing in x train, and our loss will be equals to the loss function that we defined with the pass in y pred, which we just calculated, and y train, which we're going to be comparing it to. So we did our forward pass, and we got our loss function where we're basically calculating what we got to what it really should be. And then this is the cool part. You can use this backward function to compute to get the sum of the gradients using the chain rule. So this is a really cool function in PyTorch, which makes this so easy. because it's basically getting like all the calculations you need like all the way down the line with just this one function. Okay, so also something that's probably recommended is that you do you zero out optimizer, zero grad, so that they don't compound. Okay, so you do that, then you run the backward, and after that you can update the weights, and I call this optim, not optimizer. Let's just call it optimizer. Okay, why am I being fancy here? Optimizer. And then what we'll say is we got to update, so we'll say optimizer.step. Okay, and that's it. Now let's run this, see if I get any errors. Let me go into my handy dandy console here. Let's run this, see what happens. Okay, nothing, no errors, no nothing. Okay, awesome. Now let's actually, I guess, see if it worked. So let me open up Excel here and see what we got. Okay, years experience and salary. Alright, so let's say we want to calculate, I don't know, estimated 6 years of experience, what your salary should be, which in this case is, I don't know, around 90-something thousand. Okay, so what we're going to do is we're going to basically create some dummy data. We're going to say test experience, test exp, and then we'll say is equals to a torch float tensor, and what did we say, 6? So let's do 6.0. Okay, then we could just print this out, making it really explicit. So we're saying if you have 6 years experience, salary is, alright, now we'll say model, and we're going to pass in test experience, and then to sort of get this information that we want, we have to access something. So we'll say 0, 0 using just simple Python array indexing notation, and then we're going to get the item, the actual data in there. So let's see what it says. You know what, let's run a couple more. Let's print this so that you can actually see what's happening at each iteration. So what I'm going to do is something like right after here, I'm going to say print, and we'll say loss.data. Okay, and we'll see what's in there, and hopefully if we did something right, it should be getting smaller. So here we see, let's see, nine places to the right, 9 zeros, and then is this getting smaller? I think it is. Sorry, I'm not very smart. Okay, so let's we didn't get a good result, so let's do like more iterations, see what happens. Let's do like 500. And what were we trying to get? Again, you would like, if you were doing this for real, you would want like a test set, okay, to actually test it. But we're here just for manually testing. So 6 years, 90-something thousand. Should be in the 90s. So let's do 500, and see how cool it is? You can just change the number of iterations you want to do and train it that many more times. So okay, so not beautiful, but what I kind of wanted to show is just how PyTorch sort of like the flow is, and you could have just done this with like you could just fit a line with like scikit-learn or something. You don't need PyTorch for this, but anyway, it's fun. Let's just see right now, just for the heck of it. I have matplotlib imported, pyplot, and what I'm going to do is I want to see what this loss looks like. So I'm going to do a plot. We're going to make a scatter plot and pass in the epoch. And let's see, let's make it just red. Pass in these parameters that it needs, that pyplot needs, and we'll make this the O marker. Now, I think this should work. I just want to basically plot the loss function as it decreases. So then we'll just do plt.show. Let's try that. Okay, there we go. So as you can see, as more epochs happen, the loss decreases. Let's make this more explicit even, so that you can, so it makes sense. plt.x label epochs, and we'll just do y epochs. Let me see if this changed anything. I don't think so. Okay. Alright, so there we go. As our epochs happen, as more training happens, you can see the loss decreases, at which point it starts like kind of slowing down, and it doesn't make sense to do more epochs. That's why if I did like 1,000 here, I'd probably still get like a pretty similar result to this. So anyway, guys, that's it. That's a totally unnecessary, simple regression in PyTorch. I hope you learned something. If I missed something like totally fundamental and I screwed something up, which is 100% possible, let me know and please correct me. Still learning PyTorch. I really like it though. Give it a look. Check out the docs. Got pretty good docs. Alright. Thank you for watching. Catch you next time.